on here, and this is number 34. You may also, if you have your binder and it's organized, you may want to take out 31. 31 will help you fill in these blanks. So 31 I gave you on Tuesday. It has all the properties of equality and congruency statements on them. Really on Tuesday, we just talked about this top box. The top box was addition property of equality. So when you're adding to both sides, subtraction property of equality. So when you're subtracting. Huh? Yeah, the table of contents. Yeah. So it talked about subtraction property of equality. That's when you subtract to both sides. Multiplication property of equality when you multiply to both sides. Division property of equality when you divide to both sides. So we are really adding on to that today. We're still going to use those, but then we're also going to talk about properties of congruence. So if you have properties of equality, that is when you have an equal sign. So you literally have an equation. When you are talking about properties of congruence, you have a congruency symbol. So notice in this second box, you have a congruency symbol in every single one of these statements. So a congruency symbol is an equal sign with a squiggle on top. It basically means the same thing. It means they're equal, but these are your properties of congruence. Reflexive property is stating the same thing over again. Symmetric property is like a mirror image of itself. So for example, angle A is congruent to angle B. Then I could say the opposite. I could say angle B is congruent to angle A. The one that we're really going to be using next week as well is transitive property. Go get a chart pass. Why are you shocked? I don't understand. So where did you go?
The bathroom.
Okay, go get a chart pass. Transitive property is when you have something like angle A is congruent to angle B and B is congruent to angle C. Then we could say angle C is congruent to angle A because we're taking out that middle angle. So we're taking out whatever's connecting them and we could just take the two end pieces and put them together. So this is kind of what we're adding in today. Distributive property is when you have parentheses and you're distributing into your parentheses. We're also going to be using this property today. So if you want to add those in, if you have not already done so, you don't need to if you don't want to. It's just there to help you. So this piece of paper will help us today. So we're going to do a couple of them and then you'll have plenty of time at the end of class to just do this before you leave. Let's do one of the math ones to refresh our brain from Tuesday. So if we look at number 1, it says fill in the reason that justifies each step. The first thing is 2/3 x plus 6 equals 14. The reason why is because it's given. Normally you have a little word bank or drop down options. In this case, we're just going to fill it in. So from here to here, what they're doing is getting rid of the 3. They're multiplying both sides by 3. Oh, I should put it up here. Multiplying both sides by 3 to get rid of that denominator. So since I'm multiplying by 3 on both sides, people automatically think parentheses and they're like, I have to distribute to get rid of the parentheses. But I went from here to here, I put it in parentheses. So does anybody know what that property would be called if I multiplied by 3 to both sides? Yeah, multiplication POE. So this is multiplication, technically property of equality. So multiply E. And on Tuesday, we talked about we'll just shorthand it instead of writing out property of equality. So from the first step to the second step, they multiplied both sides of the equation by 3 to basically get rid of the denominator of 3. So that's multiplying. Now to go from here to here, how did they actually remove those parentheses? How do I get rid of the parentheses? Distributive property. So if I distribute into 3, thanks. Here. Wait a second. There you go.
Thank you.
So to get rid of the parentheses, I'm using the distributive property. It is not multiplication property of equality again, because I'm not doing it to both sides. I'm only doing it to this side. So this is the distributive property. Distributive prop. Now from here to here, Notice that this side went from 42 to 24 and the 18 is gone. So what did I do to go from this step to this step? Subtract. So this is subtraction property over quality. And if you need to fill in the math between the steps, you can. It'll help you. So this is subtraction property of equality. And then what about that last step? Divide by 2. So this is division property of equality. So anytime you do something to both sides of the equation, that's why it's called property of equality. Okay, let's go to number 3. Number 3 is where it's adding in the geometry. I'll keep it up here for a second. Number 3 is adding in the geometry. So it's going back to chapter 1. Chapter 1, this should look familiar to you. We used to solve these and we talked about it was like piece plus piece equals whole. So this right here is like this poster that's on this side. So it's segment addition postulate. So you're taking one piece of the segment, you're adding the other piece of the segment, and it's equaling to the whole thing. What's up? Yeah, just make sure you put POE because sub could also look like substitution. Or put like, or just put subtract. You want to shorten it because sub could be substitution because there's some substitution in here. That's actually what we're about to do. So subtraction and substitution, just make sure you put enough letters that you can tell the difference. So for number 3, it says that I have AC is 2x minus 2. CB is 4 times x plus 1. And what's given is AB is equal to 50. So from A to B, this whole distance is technically a measurement of 50. So what we did in chapter 1 is we actually solved these. We didn't talk about really the steps. We just like solved the math. So now we just have to justify the steps. So we know AB is equal to 50 because it's given. From here to here, it says AC plus CB is equal to AB. There is no numbers at all. So this is representing a theorem or a postulate. So what we're going to call this step is segment addition postulate. And remember, when you're doing this on your own, on your like chapter 3 test and stuff, you never have to actually fill it in like completely by yourself. And will have a word bank. So this is segment addition postulate because you're taking your pieces of your segment, you're adding them together to make your whole. So from here to here, we went from all letters to plugging in numbers. So if I have a problem that I'm taking letters and I'm replacing them with numbers, because I know AC is 2x minus 2, and I know CB is 4 times x minus 1, and I know the whole length is 50, what is that technically called in math when I replace letters with numbers? Think back to like 6th grade, 7th grade. It's when you would have started using this property technically. If I take a letter and I replace it with a number. Substitution. So this step is going to be called substitution because I'm substituting in each of these lengths. I know these lengths are equal to these little parts, so I can plug them in, replace them with substitution. So now the rest of this should be very similar to Tuesdays. So I went from this step to this step. How did I get rid of my parentheses? What property did I use, or what did I do to get rid of those parentheses? Because notice 2x is still in the front, minus 2 is still in the front, and now the 4 is technically 4x, and then I have a 1 that turned into a 4. So what happened? Distributive property. So if I distribute the 4, it's not multiplication property of equality because I'm not multiplying by 4 to both sides. So this is just the distributive property. Postulate, P-O-S-T-U-L-A-T-E. Oops, sorry. There you go. So it's like a theorem. So distributive prop. So if I distribute, now I have this. And then I went from 4 terms on the left side to now only 2 terms on the left side. So what did I do from this step to this step? Combine like terms. So they combine the x's to make 6x. They combined the -2 and the +4 to make +2. So this is combine like terms. Or simplify. If you want to put simplify, you can put simplify. Now it's a 2-step equation. I went from 6x plus 2 equals 50 to 6x equals 48. So how did we go from this to this? Subtraction property of equality. So since I'm minusing 2 to both sides to get the 2 to cancel, that is subtraction or subtract POE. And then what would be the last step? Division property of equality. So if I divide by 6 on both sides, and if it helps, you can show the math between the steps. You don't need to, but you're dividing to get your answer. Huh? What did you say? So the last step is typically division. Not all the time, but most of the time, like 80% of the time, it's going to be division. So when in doubt, put division, I guess. And then we're going to fill out the last bottom part together. So the last bottom part is going to be very helpful if you have this piece of paper out. This piece of paper has the answers on it. Okay. So it says, name the property of equality. So that's like your equal sign. Or congruence. Congruence is the squiggle that justifies going from the first step to the second step. So notice number 4 has a congruency statement. It has a congruency symbol. So I am not looking at the properties of equalities. You should be looking at your sheet and you should be looking at the second box. There's only 3 options. So you have a 1/3 chance of getting it correct. So if I look at this, it says XY is congruent to TZ. TZ is congruent to XY. So it's literally replacing it. It's just flip-flopping it. So on your properties of congruence, because you have a congruency symbol, which one would best represent that out of these 3 options? Symmetric, because if you look at symmetric, it's just literally flip-flopping it. It's like a mirror. Think symmetry. It's literally identical. Nothing's changed. So it's symmetric. I spelled that wrong. I suck at spelling. Sorry, guys. Symmetric property of congruence. So the reason why it's property of congruence this time is because you have a congruency symbol, which makes sense. Let's do number 6 just because it's like right below it. Number 6 says 4n plus 6 minus 2n equals 9. And then it goes 2n plus 6 equals 9. So what did they technically do? Combine like terms because they combined the n's. It says, this is like a scribble that says symmetric prop of congruence or symmetric property of congruence. Do you need me to zoom in? Why do you choose to sit in the back? All the blind people, I have a blind person in 6th period that not blind, like not literally blind, but like blind like him. Like he can see, but he can't see great. So I call him blind. But like you sit in the back and you chose to sit in the back, but you're blind. And then like 6th period, there's a guy that's the same way. And I'm like, why did you choose? Like, you guys don't have the side seats. I don't understand. And then I'm pretty sure there's somebody in my 1st period that's the same way. I'm like, why sit in the back? If you just don't have to sit where you're sitting, you don't have the side seats. You can mix it up. People just came in on the first day and like chose their spot and we're like, this is my spot forever. Okay. So I want you to start with number 2. They are not that hard. You have to try. Start with number 2, work your way around. You will get done with this in class. It is not bad. It is not hard. Let me know if you get stuck. You should not. Last period had like a spare 10 minutes on their hands. Yes. Yeah, take pass.
No retaliation. No retaliation.